In this video, let us discuss some basic applications of an op-amp. So first, let us consider op-amp adder or summing amplifier. Now let us understand what is a summing amplifier. If more than one inputs are applied to any terminals of the op-amp, then output will be addition of applied signal. Hence, it is called summing amplifier. Now, in the inverting summing amplifier, more than one input is applied to the inverting terminal of an op-amp. Hence, the name inverting summing amplifier or adder. So here it's a circuit, summing amplifier circuit using op-amp. In this circuit, input signals are applied to the inverting input terminal and non-inverting terminal is grounded. Okay, so there are three inputs. Okay, so V1, V2 and V3. These three input signals are applied to the inverting terminal of an op-amp. So now applying KCL at node A. As op-amp input current is 0, so the entire input current flows through resistor RF. So now IF is equal to I1 plus I2 plus I3. So now here IF is equal to VA minus V0 by RF, and I1 is equal to V1 minus VA divided by R1, and I2 is equal to V2 minus VA by R2, and current I3 is equal to V3 minus VA by R3. So now this expression becomes VA minus V0 by RF is equal to V1 minus VA by R1 plus V2 minus VA by R2 plus V3 minus VA by R3. Now as point B is grounded, due to the virtual ground concept, the node A is also at the same potential. So that means VA is equal to VB is equal to 0. So now here VA is equal to 0, right? So this equation becomes minus V0 by RF is equal to V1 by R1 plus V2 by R2 plus V3 by R3. So the output voltage V0 is equal to minus RF into V1 by R1 plus V2 by R2 plus V3 by R3. Now if R1 is equal to R2 is equal to R3 is equal to R, then output voltage V0 is equal to minus RF by R into V1 plus V2 plus V3. So now if RF is equal to R, then the output voltage V0 is equal to minus of V1 plus V2 plus V3. So now due to the negative sign of the sum at the output, it is called inverting summing amplifier. So now let us discuss one more application of an as voltage follower. So your voltage follower is also called as buffer. In this voltage follower, the output voltage follows the input voltage. The circuit in which the output voltage follows the input voltage is called voltage follower. So this is the voltage follower circuit using op-amp. So now from the circuit, potential at node P is equal to VB is equal to V in. Now, from the concept of virtual ground, two input terminals are at the same potential. So therefore, VA is equal to VB is equal to Vin. So here node A is directly connected to the output. So hence output voltage V0 is equal to VA. Since VA is equal to Vin, okay, so VA is equal to Vin, right? Therefore, output is equal to input. V0 is equal to Vin. So now this voltage follower is a special case of non-inverting operational amplifier. Right? So here in this circuit, output signal is in phase with the input signal. So now if we make R1 is equal to infinity and feedback resistor RF is equal to 0 in the non-inverting amplifier circuit, then the circuit becomes voltage follower circuit. And closed loop gain of this circuit is equal to 1. That is voltage follower gain is unity. Okay, so this voltage follower is also called as source follower, unity gain amplifier, or buffer amplifier, or isolation amplifier. So here closed loop gain of the circuit is 1. So that means output follows the input. Whatever the input you give, output will follow the input. And the circuit does not provide any amplification. So now let us see the output and input. See this is the output waveform. Output follows the input. So now these are the advantages of voltage follower. It has very large input resistance, very low output resistance, and it provides large bandwidth, and output follows the input exactly without any phase shift. So here now this voltage or follower circuit is used in many of the application as a isolator, and it is also used in impedance matching. So this is about a voltage follower circuit.